Hey guys, my name is Ganesh and I'm here with Rodrigo Verberg, and today we're going to be talking about a resume parsing model. Okay, can I get a show of hands here of people who have struggled to find a job that matches their skill set? How often do you feel that you're a good fit for a role, and then within 24 hours, you submit for that job and you get a rejection notice from the HR filter? Haven't we all gone through a roller coaster of emotions when we search for our next job? Folks, let me tell you something. I relate to that a lot. The competition's fierce out there. We got a solution for y'all. Our solution is an LLM model that takes a resume or both a resume and job description as inputs and utilizes several advanced techniques to output a report and optimized resume. The picture in the top right is a popular meme within the AI community called Shogut with a smiley face, in which Shogut is a literary reference to a vast, complex, and incomprehensible monster. In the same manner, LLMs are complex, powerful, but unintelligible at their base, since they understand tokens, not the English language. Thus, some refinement techniques can be used to harness the power of LLMs and produce an output we desire, such as the smiley face example, in which, in our case, we utilize ChatGPT as our base large language model, which is an already refined LLM, and added hybrid or contextual querying with the high quality textbook like data, self-refinement prompt engineering techniques, and fine-tuning with the output of classification models. This then creates, in our point of view, another smiley face coming out of a smiley face shown here. Moving on to methodology employed. This slide goes through the embedding process. We can start with the data is selected to improve our model. We were motivated by the paper, Textbooks Are All You Need, which suggested that just like humans might struggle to learn from noisy and incomplete data, LLMs also struggle to learn from this kind of data quality. Thus, we chose the Ultimate Tech Resume Guide, which is an extensive document that provides best practices across a variety of scenarios for resume generation. We then split the text into chunks so that the model can handle the input because of token limits. It is also beneficial because the model can search more efficiently this way. The text was then converted to embeddings, which are numerical representations of the text. Then the embedding goes through the semantic vectorization so that the model can understand these numerical representations, which are then stored in a Chroma vector database for efficient retrieval. So next we can talk about hybrid querying for contextual information retrieval. Hybrid querying combines retrieval and retrieval-based and generative techniques. Thus, we're able to ask questions about the embedded document and generate contextually aware and tailored outputs. In our case, our embedded document was the Ultimate Tech Resume Guide. Prompt engineering was also a technique used to improve our output. We defined the task, broke it down into components, which were to analyze the resume and identify their situation, then look up the best practices and apply them to a report. Then apply the recommendations to an optimized version of the resume. Special prompting was applied to identify hallucinations and mark them as recommendations with additional information not given. Then some self-refinement techniques were used to refine the output. This technique has shown to improve in research approximately by 20%, absolute improvement on the average in-task performance across all evaluated tasks. Thus, a simple technique and effective one that should not be ignored. In our case, it is also effective in several cases where the output did not recognize issues like career breaks or other special circumstances. Next slide. Moving on to the future evaluation and future improvement of the model. For the evaluation, we believe that traditional methods of evaluating LLMs, such as Perplexity, Blue, Rogue, Meteor, are not suited for our use case. Other ways of evaluating LLMs are on specific tests that a human can perform, such as math, coding challenges, or other tests. In our case, creating resumes is more of a subjective task, which is harder to evaluate objectively. However, we believe we can still track some custom metrics, such as pieces of information missed per 100, hallucinations per 100 resumes. We could also potentially track real-world outcomes in A and B testing, such as interviews, but that would be a very difficult thing to implement practically. In our opinion, human feedback is the best evaluation method we have and plays a critical role in improving the model. We would ideally want a human evaluator who has domain expertise in resume generation. Then their components, if any, would be used to refine data or for creation of synthetic data for further improvement of the model. Another technique we wish to employ further is to improve the model using fine-tuning with the output of classification models. For example, a classification model that a given resume, the model outputs the most relevant job titles. So in this output, it can be used further to improve the model to generate better reports and make suggestions for other job titles a user might want to consider. With that, I'm going to hand it off to Rodrigo, who's going to show you a little bit of a demo of our resume parsing model. Rodrigo?
For the demo, we can see a response. This is the response we get. This is the initial report, and then this is the optimized resume. So we can see several things that the input is a resume, a job description, and then a special. Special is just something extra that a user might want to give the model, such as extra information, such as I took a career break, or I took a sabbatical, I am switching careers, I'm in college, any extra information that a user wants to let the model know, so it can tailor it better. So here are some recommendations. So it identified the user as a data scientist with 7 years of experience. So we can just quickly see that add a bullet point in the skills section, major cloud computing platform, specifically Azure, right? So we can see it's giving very detailed information. And then over here, we can see that this recommendation, so we specifically, in the resume itself, we asked the model to output it like this, so that um, a person knows that um, this is something they don't have yet, right? Because they did not give us this information specifically, so we don't want to do any hallucinations without letting the user know. So this is just a recommendation that was not included in the information they gave us in their resume. So this is something extra that the model thinks is important to align it better to the job. So then we can see a refined prompt. So the refined prompt takes in the result of the previous um, output, the special, same thing, and today's date, right? It just so that it can see if there is a career gap, or just so that the dates align and everything else. After that, it outputs the the result in a kind of Python dictionary, and this is a function so that it can actually create the output into an actual resume in a Word document. So after feeding this into the create resume function, we can see that this is the resume that was output it from the model. So with this, we finish the demo, and it's Ganesh turn. I'll hand it over to Ganesh.
Thank you, Rodrigo. So highlights here, guys. This is still proof of concept. We're in seed round and we're requesting 50K. This will get our product deployed and help us with our initial customer acquisition. Our customer acquisition costs are around $5. Now, keep in mind, this is variable and it needs to be tested. Right here are our economic assumptions. Cloud storage per user is expected to be lower as we get more users. The other thing is we also got OpenAI API calls, and that's 0.006 cents per 3,000 tokens. So if you put it into perspective, 1,500 words is 2,048 tokens. So that's 3 pages right there. And our profit per customer is about $3.49 per customer. Next is our market opportunity. We did a TAM, SAM, SOM Venn diagram. Out here, the global IT staffing market is about $115 billion. That is our total addressable market. In the US alone, there's 161 million people that are employed. And if we collect $10 from each one of them, that's going to be our serviceable addressable market. And that's about 16 billion. Our serviceable obtainable market is going to be, out of the 161 million, 9.4 million people in the tech sector alone, and we're focused on that, and we collect $10 from them. That's about 940 million. That's our serviceable obtainable market. With that, I'd like to, in conclusion, our vision and future plan are as follows. We want to incorporate fine-tuned data. This augments the model's recommendations, make them more relevant to specific job roles. We want to create a feedback loop with human reviewers. This ensures the LLM responses are aligned with human expertise. We want to apply iterative refinement techniques. This allows the LLMs to learn and adjust from past errors. And last but not least, expand beyond tech-related resumes. This addresses a wider audience and caters to various job seekers' needs. With that, thank you very much, guys. Have a wonderful day. Bye.